Hey guys, welcome back to my channel. Today we'll be solving all the subparts of question number 5, exercise 8a, OP Malhotra's textbook for ISC Mathematics. So let's begin. So first of all we have the differentiation of x cube upon 3x minus 2. For this, we will be using the u by v rule. The differentiation of u by v is v into the differentiation of u minus u into the differentiation of v upon v square. So we have 3x minus 2 into the differentiation of x cube, which is 3x square, minus x cube into the differentiation of 3x minus 2, which would be 3 into the differentiation of x, which is 1. So 3 minus 2 becomes 0 because minus 2 is a constant. So this becomes 3. 3x minus 2 differentiation is just 3 upon 3x minus 2 the whole square. So this becomes 3x into 3x square minus 2 into 3x square minus 3x cube upon 3x minus 2 the whole square, which becomes 9x cube minus 6x square minus 3x cube upon 3x minus 2 the whole square, which ultimately becomes 6 into x cube minus x square upon 3x minus 2 the whole square. And of course we can take out x square common from this, so it becomes 6x square into x minus 1. Let me just erase that for you. So this becomes 6x square into x minus 1. And that's the final answer. Let me write it once again. 6x square into x minus 1 upon 3x minus 2 the whole square. And I would prefer not opening this bracket and not doing the whole square because it's just simpler to keep it in this way. So let's move on to the second question. Okay, so the second subpart is the differentiation of x upon sine x. Again, we will use the u by v rule. So this becomes sine x into the differentiation of x, which is 1, minus x into the differentiation of sine x, which is cos x, upon sine square x. So the final answer, sine x minus x cos x upon sine square x. Okay, so the third subpart is the differentiation of 1 plus cos x upon 1 minus cos x. Let's go ahead and use the u by v rule. So this is 1 minus cos x into the differentiation of 1 plus cos x. 1 becomes 0 and cos x becomes minus sin x after differentiating. So we have 1 minus cos x into minus sin x minus 1 plus cos x into the differentiation of 1 minus cos x. 1 becomes 0 and cos x ka differentiation is minus sin x. So minus of minus sin x becomes plus sin x. So we have sin x here upon 1 minus cos x the whole square. So this becomes minus sin x, minus cos x into minus sin x becomes plus sin x cos x, minus sin x again, and minus sin x cos x. Because there is a minus sign here, so minus into cos x into sin x becomes minus sin x cos x. And let's see if there's any benefit of opening this bracket. So this becomes 1 plus cos square x minus 2 cos x. Because the differentiation of a minus b the whole square is a square minus b square. But since there is nothing that we can do with this, I'm going to keep it simplified again in these terms, 1 minus cos x the whole square. If there was 1 minus cos square x, I could have changed it to sin square x. But since there is no more simplification possible, I will keep it like this. Since these sin x and cos x cancel out and we have 2 minus sin x, so this becomes minus 2 sin x upon 1 minus cos x the whole square. That's the final answer. Okay, so now we have the fourth subpart, which is x square minus root of 1 plus x. So let's go ahead and differentiate this as u minus v. So first we differentiate x square, which is 2x, minus, since we have the differentiation of root x, which is 1 upon 2 root x, so this becomes 1 upon 2 into root 1 plus x into the differentiation of 1 plus x. So 2x minus 1 upon 2 root 1 plus x, and we know that the differentiation of 1 would be 0 and the differentiation of x would be 1. So this ultimately becomes 1, and 1 upon 2 root 1 plus x into 1 is 1 itself, which is why this is the final answer. Moving on to the differentiation of the fifth subpart, which is sine 2x cos square x. So first of all, we'll be using the UV rule. This would be sine 2x into the differentiation of cos square x, which would be 2 cos x into the differentiation of cos x, which is minus sine x, plus cos square x into the differentiation of sine 2x, which would be cos 2x into 2. So now we have minus sine x cos x into 2 into sine 2x plus 2 cos 2x into cos square x. So now we can take out 2 cos x common, and we would be left with minus sine 2x sine x plus cos 2x cos x. So now this gives us 2 cos x into cos 3x. Let me show you why. Here we have cos x cos 2x minus sine x sine 2x. And we can see that this is the expansion of cos x plus 2x, because the expansion of cos a plus b is cos a cos b minus sine a sine b, which is similar to what we have here. X and 2x prove to be a and b respectively, which is why we can write this whole term as cos x plus 2x, which is cos 3x. So now we have 2 cos x cos 3x, and we know that cos c plus cos d is equal to 2 cos c plus d by 2 cos c minus d by 2. We know that 2 cos a cos b is equal to cos a plus b plus cos a minus b. This entire thing comes from this thing. So we are going to be using this 2 cos a cos b is equal to cos a plus b plus cos a minus b. This is also written in your textbook. So we have 2 cos x cos 3x, which we can write as cos x plus 3x plus cos x minus 3x. Cos x plus 3x becomes cos 4x plus cos minus 2x. But we know that cos of a minus angle is the same thing as cos of a positive angle. Cos of the negative angle is the same thing as the cos of the positive angle. So this becomes cos 4x plus cos 2x. We ignore the minus sign when it comes to cos. So this is the final answer. Moving on to subpart number 6. We have tan raised to 4 7x. We know that the differentiation of this, first of all, we would differentiate this raised to the power 4, and x raised to the power 4 would be 4x cubed, the differentiation. So this becomes 4 tan cube 7x into the differentiation of tan 7x. So we have 4 tan cube 7x, and we know that the differentiation of tan 7x would be sec square 7x into the differentiation of 7x, which would be 7. So the final answer would be 28x tan cube 7x sec square 7x. Going on to the 7th sub question, which is 1 upon sin x cos x plus 1 upon sin x plus cos x. Using the u by v rule, we have sin x plus cos x into the differentiation of 1, which is 0, minus 1 into the differentiation of sin x plus cos x. Upon sin x plus cos x the whole square. So the first part becomes 0 because of multiplication with 0. Then we have minus 1 is minus, I'm just adding the minus. And then the differentiation of sin x is cos x, and the differentiation of cos x is minus sin x upon sin x plus cos x the whole square. So let's do the square. This becomes sin square x plus cos square x plus 2 sin x cos x. So this becomes minus cos x plus sin x. I'm writing that as sin x minus cos x upon, we know that sin square x plus cos square x is 1, and 2 sin x cos x is the expansion of sin 2x. So this becomes plus sin 2x. So this is the final answer. Moving on to the final question of today, which is the 8th subpart of question number 5. 1 plus cos x upon x. Now we could do this in two ways. I could write this as 1 by x plus cos x by x, and I know that the differentiation of 1 by x is minus 1 by x square, and I would differentiate this by the u by v rule. But for now, let's just use the u by v rule on the whole thing. This was just another way. And in the previous question also, I could have multiplied sin x minus cos x in the numerator and denominator and differentiated it in another way. So let's go on with this. This becomes x into the differentiation of 1 plus cos x minus 1 plus cos x into the differentiation of x, which we know is 1. So I am keeping it like this, upon x square, which becomes x into the differentiation of 1 is 0, and the differentiation of cos x is minus sin x, minus 1 minus cos x upon x square. So we have minus x sin x minus 1 minus cos x upon x square. And please note that the answer given in the textbook is incorrect. It has to be minus 1 into x sin x plus 1 plus cos x upon x square. They have missed out on this minus 1 in the textbook, and this is the correct answer. So guys, that's it for today. Thank you so much for watching. I'll see you in the next video. Bye.